Now for the concavity and inflection points. I need a second derivative. So f double prime of x, looking back at f prime and doing a power rule, again, we should have 110 x to the 9th minus 540 x to the 8th, I guess, equal to 0 or undefined. As before, it turns out we're really just looking at equal to 0. So we factor just like the first derivative test. There's really no difference. There's no difference between the first derivative test and the test for concavity and inflection points, except that you're dealing with the second derivative and different results. But the methodology is exactly the same. So we're going to factor off the factor of 10 they have in common and the x to the 8th that they have in common. And we're left with 11x minus 54, all equal to 0. So now we have x could be 0 because of this factor, or x could be 54/11ths because of the second factor. And these are not called critical values because they're coming from the second derivative. And they are called possible inflection points, but they don't have to be inflection points any more than the critical values have to be relative extrema, right? It's not a necessary result. Possible inflection points. But our test here will determine whether they actually are or not inflection points. All right, so making another sign chart, but this time for the second derivative. So our sign chart has on 0 again, but 54/11ths, slightly before the 60/11ths value we had a minute ago. So I'll make it look just a little bit closer, maybe. It'll turn out that way, 54/11ths. The 60/11ths was a little bit over here, perhaps. And we know what's going on with f. Okay, so there's our sign chart. So now we need to do the same thing again. We need to take a test case and figure out from each interval what the sign of the second derivative is. Now this time I have to be a little more careful because the x to the 8th here, this factor is not to an odd power, right? So the 0 here does not have an odd multiplicity, it has an even multiplicity, right? It's multiplicity 8, even though this one is odd multiplicity. So we've got to just be a little more careful. What that really means is there will be no sign change around the root coming from this factor. So I anticipate down here that around the 0 location, right, because that root corresponds to the even multiplicity here, that there will be no sign change across 0. Now I don't know what the sign is yet over here, but I'm pretty confident it's not going to change. Okay? But then because the 54/11ths is coming from a factor which has an odd power to it, power 1, so this is multiplicity 1 root, the sign should change as we move across 54/11ths, but it still doesn't tell me what the sign is on either side. So I still need to take a test case of at least one location, and I can probably figure out the rest. I'll do the same thing I did last time. I'm going to take an extremely large positive number. So that will force the 11x minus 54 to become positive. I take a very large positive number, multiply it by 11, subtract 54, it will still be positive. So this factor is positive for very large x. And of course the 8th power of x is positive for any positive value. So positive times positive is positive. Therefore the second derivative is positive for large x past 54/11ths. Now I said at 54/11ths the sign should change, so this should be a negative here. And I said at the 0 location the sign should not change, so I use a negative here. If you're not comfortable with everything I just said, then always just use test cases for every single interval so it doesn't get messed up. All right? But the logic I'm using, I hope, is pretty clear and can save you a lot of computations. So now we know, instead of saying f is decreasing, decreasing, increasing, that's not what the second derivative tells us about f. It tells us that it's concave up. So concave up and down, concave down here, concave down here, concave up. Here's what we now know. So now we have finished the problem. So C and D. C is concave up on 54/11ths to infinity. To infinity. Concave down on negative infinity all the way, it includes 0, all the way to 54/11ths. Okay? And now we know the only inflection point for part D is where the sign of the second derivative changed at 54/11ths. At 54/11ths, comma something. So now I have to plug it back into the original function to find out that value. So it'll be just as cumbersome as the 60/11ths was a minute ago. So it'll be 54/11ths to the 11th power minus 6 times 54/11ths to the 10th power. I'm going to use the same scheme I did a minute ago. I'm going to factor off the 54/11ths to the 10th power. I'll be left with a 54/11ths minus 6. But 6 is really 66/11ths. 54 minus 66 is negative 12. So I get a negative 12/11ths here. So I'll end up with negative 12 times 54 to the 10th, but the 11 on the bottom will be to the 11th power. And that will be my y value for the inflection point. So negative 12, 54 to the 10th over 11 to the 11th should be our answer for the inflection point.